with one that some students take for granted, and that's our measurement conversions. So when we're doing our measurement conversions, we have our standard measurements and we have our metric measurements. Let's start out with the metric measurements. Remember, in the metric system, we have our three main units. We have the unit of length, which is the meter, the unit of capacity, which is the liter, and the unit of mass, which is the gram. In the metric system, we tend not to use the unit of force outside of engineering and scientific applications. And as they get smaller, remember it's deci, then centi, then milli. And then it would skip up to the millionth would be micro, and the billionth would be nano, and it would keep going. Getting larger, we have deca for 10, 100 is hecto, and 1,000 is kilo. So converting in the metric system is just a matter of moving the decimal point, because each position on this chart is either multiplying by 10 or dividing by 10. So each position on that chart is moving the decimal point one spot. So if I want to convert 280 meters into centimeters, what I'm looking at on the chart, I am going from meters to centimeters. So from meters to centimeters on my chart is 2 spots to the right. What does that do to my decimal point? It has to move 2 spots to the right, so we're going to have to fill in zeros. So 280 meters is 28,000 centimeters. If I have 730 milliliters, I need to convert it into centiliters. Same type of thing, milliliters to centiliters. On the chart, here's milliliters. To get to centiliters, I move 1 spot to the left. So that means my decimal point has to move 1 spot to the left. 73 centiliters. If you do not have this little chart here written down somewhere in your notes, here is your last chance to get it written down, because that is the key to doing metric conversions, is having that chart. Okay, so that's if it's just standard measurement. Length, we've got the capacities and the masses, of course, aren't going to change. The length measurements will follow this chart. But remember, those length measurements can sometimes get used for areas. So if they're being used for areas, they would look like this. They might be 5.7 centimeters squared being converted into millimeters squared. Now on the chart, we're going from centimeters to millimeters, which is 1 spot to the right. But it's not length units anymore. It's area units. It's squared. And that squared, that power of 2 means every spot on the chart is now multiplying or dividing by 100. So we have to double the number of decimal places we move. So even though it's one spot to the right on the chart, our decimal point moves 2 spots to the right. So it's 570 millimeters squared. Or we might have 47,000 centimeters squared going into meters squared. Centimeters to meters is 2 spots to the left. Our decimal point, remember, moves 2 for each spot on the chart now because it's squared. So 2 spots to the left becomes 4 decimal places. So 1, 2, 3, 4, 4.7 meters squared. The next step was to talk about volume. Remember, when we're dealing with volume, we're not dealing with squared units anymore, we're dealing with cubed units. So we might have two, well, let's make this a little more reasonable. We might have 0.028 meters cubed. If I'm converting that into millimeters cubed, on my chart, going from meters to millimeters is 3 spots to the right. But it's not meters or square meters even, it's cubic meters to cubic milliliters. That power of 3 means each spot on the chart is how many decimal places? 3, right? Because it's cubed. So it's 3, 6, 9 decimal places that the decimal point has to move. So we go 1, 2, 3, and then we have to add zeros, 4, 5, 6, 7, 8, 9. So that is 28 million millimeters cubed. Or we might have 29,000 millimeters cubed going into centimeters cubed. On the chart, millimeters to centimeters is 1 spot to the left, so my decimal point has to go 3 times that, so 3 spots to the left. 1, 2, 3, that's 29 centimeters cubed. So the metric system is pretty simple. It's just a matter of moving on the chart. You just have to be careful to make sure you see if there's units squared or units cubed, which changes that. Yeah, any questions? Because from millimeters to centimeters, there's only 1 spot to the left on the chart. Well, yeah, the triple 1 is 3, yes. For our US measurements, I got to stop myself from calling them standard because they're not considered standard anymore. For our US measurement, remember our conversions are not as neat. They're not just moving the decimal place anymore. So we have to deal with conversion factors. For example, if I have 4 rods and I want to convert it into yards, most of us do not know that conversion off the top of our head. So we're going to go ahead and make a conversion factor. So we start out by turning our 4 rods into a fraction, 4 rods over 1. Then we're going to multiply by this conversion factor, or a unity fraction it's sometimes called. The unit we are getting rid of goes on bottom. So rods is going to go on bottom. And we're converting to yards. So yards is going to go on top. Our relationship between yards and rods is that 1 rod is 5.5 or 5.5 yards. So the rods cancel out. 4 times 5.5 yards is 22 yards. On bottom, we have 1 times 1 is 1. So it's just the 22 yards. Now, often there's going to be multiple steps you have to go through. We might have 64 pints, and we want to convert that into gallons. We put our 64 pints over 1. We're getting rid of pints, so we're going to put pints on bottom. But we don't have an equivalency directly from pints to gallons. So we're going to go from pints to quarts. 1 quart is 2 pints. Now at this point, pints have canceled out and we are in quarts. But we don't want quarts, we want to get to gallons. So we're going to put quarts on bottom to cancel them out and go to gallons. 1 gallon is 4 quarts. And now the quarts have canceled out and we are left with gallons. 64 times 1 times 1 is 1, or 64 times 1 gallon is 64 gallons. On bottom, we have 1 times 2 times 4 is 8. 64 gallons divided by 8 is 8 gallons. So 64 pints is 8 gallons. We even had things like $200 quarts per minute. We want to convert that to gallons per hour. So I put 200 quarts over 1 minute. Remember, a rate really is a fraction. First thing I want to get rid of, I want to get rid of either quarts or minutes. I'll get rid of the quarts first. I'll put quarts on bottom. We need to go from quarts to gallons. So I'll put gallons on top. 1 gallon is 4 quarts. So the quarts are gone. Next, I want to get rid of minutes. Since minutes are bottom, I'm going to put minutes on top to cancel them out. And we are converting from minutes to hours. So 1 hour is 60 minutes. Now the minutes are gone. Now we have gallons on top, hours on bottom, which is what we want. 200 times 1 gallon times 60 is 12,000 gallons. And on bottom, 1 times 4 times 1 hour is 4 hours, which divides out to be 3,000 gallons per hour. Any questions so far? Remember, with our standard units or US units, we do still have to be careful with the areas and volumes. We might have 4 square yards going into square feet. We're going to put our 4 yards squared over 1. We're getting rid of square yards. It's going to go on bottom. Square feet are going to go on top. What is, however, a relationship between square feet and square yards? Anybody? 9 square feet. 1 square yard is 9 square feet. Very good. There are 3 feet in a yard, and since it's square yards, it's 3 by 3, or 9 square feet. So now 4 times 9 square feet is 36 square feet. 1 times 1 is 1, so that is just 36 square feet. we might have 3,456 cubic inches going into cubic feet. So we'll put our 3,456 inches cubed over 1. We're going to put inches cubed on the bottom of our conversion factor, going to cubic feet on the top. 1 cubic foot is how many cubic inches? 144 would be square inches to square feet. Perfect. It's 12 by 12 by 12, or 1,728. Now the cubic inches cancels out. 3,456 times 1 cubic foot is 3,456 cubic feet. 1 times 1728 is 1728. We divide that out. 3,456 divided by 1728 is 2 cubic feet. Any questions? I'm going to have you guys try a couple. .4 centimeters cubed into millimeters cubed. 280 centimeters squared into meters squared. 3,700 grams into kilograms. 14 pounds into ounces. 5 square feet into square inches. And 837 cubic feet into cubic yards. I'm going to have you try those quick, and we'll talk about them in just a couple. Okay, let's see how you did on the conversions here. 1.4 centimeters cubed to millimeters cubed. What'd you get? 1,400. Very good. It's one spot to the right on the chart, but because it's cubed, each spot is 3 decimal places. 280 centimeters squared to meters squared. What do you get? 0.028. Good. It's 2 spots on the chart from centimeters to meters, but it's squared, so you have to double that. So the decimal point goes 4 spots to the left. 3,700 grams to kilograms. What do we get? 3.7 is from grams to kilograms is 3 spots to the left on the chart. 14 pounds into ounces. What do you get? 224. Perfect. 5 square feet into square inches. 720. There we go. Because 1 square foot is 144 square inches. So 5 times 144 is 720. I think you doubled it and got 24 rather than, yep, instead of 12 times 12. That is very common. So. Okay, then the last one here, 837 cubic feet into cubic yards. What do we get? Careful, you did square feet into square yards. There you said it. So yes, our cubic feet into cubic yards. 1 cubic yard is 27 cubic feet. So 837 cubic yards over 27, that is 31. Any questions on those? It's just a matter of being very, very careful. So that's our measurement conversions for the most part, but we do have to remember how to convert from standard to metric and metric to standard. You know, we might be given something like 4 gallons and convert into liters. How would we do that? Well, you'd have to look up, remember in your book, you have that conversion page that has all the conversions from metric to standard on it. And I'm going from gallons into liters. One gallon is I believe your book says 3.79 liters. I normally do 3.785, but we'll stick to what your book says. So then the gallons cancel out and it will be 4 times 3.79. So 15.16 liters. Or you might have 10 meters into inches. Now I don't have a direct conversion in my head here from meters to inches, but there is one, excuse me. There should be one in your textbook, but I'm going to do this. 10 meters is 1,000 centimeters, and I know a conversion from centimeters into inches. 1 inch is 2.54 centimeters. Centimeters cancel out. We've got 1,000 times 1 inch is 1,000 inches. 1 times 2.54 is 2.54. And we just have to divide that out. 1,000 divided by 2.54. So 393.7 inches. Any questions there? The next thing we'll need to be able to do is angles. And in angles, there are 4 or 5 relationships we need to know. We need to know complementary, supplementary, vertical. Remember, vertical angles are equal. Those are on opposite sides of intersecting lines. And then there are the parallel line relationships that we need to know. And we need to know perpendicular. So if I give you that this angle here is 42 degrees, what is this angle right here? 42 degrees. Those are vertical angles. What's this angle right here have to be? $138 degrees. It's 180 minus the 42 to get 138 degrees. Those are the supplementary angles. Pretend those lines are parallel. If I give you that this angle here is 52 degrees, and I want to know what this angle here is, what is it? Well, okay. Nobody's going to be brave, so let's see what we can figure out. What's this angle here have to be? 52. Are there any other angles that have to be 52? This one? And then there's one other one, this one here, right? Those are all 52 degrees. Now, I can't find the red one directly, but I do know what this purple one here has to be. It has to be 128. How did I get that? Yes, 180 degrees minus 52. Those are supplementary. Once I know that that's 128, this here, if this is a right angle, this is also a right angle, correct? So that's just 128 minus 90, or 38 degrees. Or I could have shortened it up a little bit. If that's a right angle, this is also a right angle here. The 52 and the 38 are complementary. 90 minus 52 gives me 38. So I could have gone about that a couple of different ways. So if I have two shapes where one is an enlargement of the other, and let's say I know those two lengths, the 4 feet and the 8 feet on those two sides. And I want to find sides X and Y here. How do I go about doing that? Well, I have to look for a side that has a corresponding side between the two figures where I know the length on both figures. Do I have that here? the 6 and the 4. Ones from each figure, they are the corresponding side. They're the same side from before and after the enlargement. So we know that one of the relationships here is the 8 and the, or sorry, 8, I said it now too. That's okay. The 6 and the 4 are related to each other. Now, if I'm trying to find x, where is the x going to go, with the 6 or with the 4? With the 4, because it's from the same figure as the 4. So x goes down here. What goes above the x? The 30 is the corresponding side from the other figure. So now to find x, we cross, multiply, and divide. 4 times 30 is 120. Divided by 6 is 20. So x here is 20 feet long. To find y, we still have that relationship of 6 and 4. Is y going to go with the 6 or with the 4? The 6. It's from the same figure as the 6. What goes below the y? The 8, because the 8 is the corresponding side from the other figure. So now we will cross multiply. What two numbers do we multiply? 6 times 8 are on the diagonal of each other. That's 48. And we divide by the 4 gives us that y equals 12. So 12 feet is y. What do you think? Not terrible? Better than angles? The biggest thing with angles is just seeing all the combinations. And sometimes what you're looking for is a couple of steps deep from what you're given. In your notes, I want you to see if you can find side x for me. Tell me what to do. Well, the 60 and the 11 are legs. In other words, they form the right angle of a right triangle. X is the hypotenuse. So if I call the two legs A and B and the hypotenuse side C, we know A squared plus B squared equals C squared. So that gives us 60 squared plus 11 squared equals x squared. So I'm going to square 60 squared is 3,600. 11 squared is 121. Still equals x squared. So 3,600 and 121 is 3,721 equals x squared. And our last step is to square root. X equals 61. The others are in inches, so that is in inches as well. Did anybody get that one? Had it? Just weren't confident of it? Yeah. Oh, sure. So we're going to look at another right triangle. I want you to try to find x in that one for me. Anybody want to be brave here? Perfect. Yes. Yes. X and the 20 are the legs. So yes, it'll be x squared plus 20 squared equals 101 squared. So x squared is just x squared. 20 squared is 400. 101 squared is 10,201. Very good. What do we do from here? Subtract 400. That gives us that x squared is 9,801. And then you square root it to get that x is 99. Any questions? Okay, that skill there is very important in some of our other areas as far as finding areas and perimeters, because there may be problems where you're missing a side to find a perimeter, but you're given the vertical and horizontal dimensions for that side. So it pops up just like that you'd have to plug them in. Also remember that problem was integral in our polar bear problem, where we started off from the North Pole, went 5 miles south, 12 miles east, and we're still 5 miles away from camp. Well, in reality, let's say we did that. We take off from a dock on the ocean, and we go 5 miles due south, and then we turn and we go 12 miles due east. Those distances are small enough, and if we're on the ocean, we're not at the North Pole, that we're not going to have to worry about the curvature of the Earth, that we can consider it to be a flat piece of paper. How far are we going to be away from the dock? Well, this would just be a squared plus b squared equals c squared. 5 squared plus 12 squared equals x squared. And we would have to calculate it out. 5 squared is 25. 12 squared is 144. Adding together 25 and 144 is 169 equals x squared. We square root, 13 equals x. So after that, we would be 13 miles away from the dock. So let's say we have a parallelogram like this. And I give you that this side here is 17 feet. That this piece here is 8 feet. And the top here is 25 feet. And I want you to find its area. Would I do, to find the area of this, would I do 20 times 17? Is that the calculation I would do to find the area? Say no. No. Okay, why not? Because remember, for area, we must have two dimensions that are perpendicular, form a right angle. So what we need here is this dimension right here. It would be 20 times that dimension. How do I find that dimension? That would, if you did 20 minus 8, that would give me this dimension. What I have here, there it is. It's a right triangle, and I have two sides. I have the 8 and the 17. Perfect. 8 squared plus x squared equals 17 squared. So 8 squared is 64, plus x squared is just x squared. 17 squared is 289. So now we subtract 64. To get that x squared is 225. And we square root. X is 15 feet. So it's 20 feet times 15 feet, which is 300 square feet is this area. What if I asked you to find the perimeter of that object? It's going to be 20 feet for this side. Do I use the 17 or the 15? The 17. Because when I find perimeter, I'm just adding up the sides. Down here, do I use the 8? It's 20. It's the whole side, which is 20. And of course, this side must also be 17. So that adds up to 74 feet of perimeter. Any questions there? What's that? If I want to find the area of this shape, what do I do? I'm going to cut it into two pieces. What's the area of piece 1? How do I find its area? 30 times 8. It is just a rectangle, yes. So that's 240. And those are inches, so that's inches squared. How about piece 2? Pi times the radius squared. The radius is going to be, well, pi times diameter would be circumference. Pi times radius times 2 would also give you the circumference. So it's pi times radius squared. Where did the 4 come from there? Yes. If it's 8 over here, it's also 8 here, which would be the diameter. So the radius would be 4 inches. Now, why am I dividing that by 2? It's only half a circle. It's not the full circle, it's just half of it. So pi times 4 squared is 50.24 divided by 2 is 25.12 square inches. We add those together to give us an area of 265.12 square inches. If I ask you to find the perimeter, well, I've got 30 here, plus 8 here, plus 30 here. Do I add another 8? No. This end is covered up. It's not part of the perimeter. What I need is this distance around here. And that distance is going to be a circumference, which will be pi times 8, pi times diameter. But is it a full circle? It's half. So pi times 8 is 25.12. Divided by 2 is 12.56. So that's 12.56 inches, which adds up to a perimeter of 80.56 inches. Any questions? What's that? Oh, it's just a matter of staying patient and picking it apart and making sure you're very careful. The big mistake people will make on this one, in either the area or the perimeter, is forgetting to divide by 2 because it's half a circle. Or on the perimeter, that's why I brought up that extra 8. They'll add that extra 8 in there because it's part of the rectangle, but it's not on the outside. It's covered up by that half a circle. Our next example is going to look something like this. Maybe not drawn to scale. Okay, definitely not drawn to scale. We're going to start out by finding the area. And yes, we are still going to find its perimeter, but we're going to start out by finding the area. Now remember, there are two methods, two strategies for finding the area. One is to divide it up into smaller pieces and add them together, which would work here, but would be kind of a pain. The second is to fill in missing pieces to make it a bigger shape, and then subtract those missing pieces back out. And here, that's the easiest way to do it. So what I need to know here, first of all, is what would the dimensions of this full rectangle be? Well, down here on bottom, what's this going to be? It'll be 26 plus 6, right? 32 inches. How about over here? $19, very good. 16 plus 3. Because this has to be 3 inches, this would have to be the 6 inches, right? Well, if this is a rectangle here, right, the opposite sides have to be equal. So if this side is 6, this side is 6. If this side is 3, this side is 3. So we have that larger area now of 32 inches times 19 inches, which is, what, 608 inches squared, I believe. But now we have to figure out what we're subtracting out. This piece is easy down here, this rectangle. That's just 6 inches by 3 inches. We're subtracting out 18 square inches there. Puts us down to 590. Up here, however, we need to know some dimensions. What's that dimension right there going to be? 7 inches, yes. The 19, which is the whole thing, minus the 12 that's there. How about here? 24 inches, very good. The 32, which is the whole thing, minus the 8 that's here. So that is a triangle that is 7 inches by 24 inches. And of course, it'll be divided by 2 because it's a triangle. 7 times 24 divided by 2 is 84 inches squared. We subtract that, we get 506 inches squared. That would be our area. Well, since we're having fun with this one, let's find its perimeter. So here we've got 12 plus 26 plus 3 plus 6 plus 16 plus 8 plus whatever this side across here is. How do I find that side? It's a right triangle here. A horizontal dimension will always form a right angle with a vertical dimension. So I know that's a right triangle. So 7 squared plus 24 squared equals x squared, which gives me 49 plus 576, which is 625, square root of which makes this 25 inches. So I add 25 inches to that, which is going to give me 96 inches of perimeter. Any questions? This looks like a good spot to take a short break. Hopefully everybody still comes back after break after that first hour. It's about 10:06. It'll be 10:07 here in just a second. So let's come back at 10:17. Well, our next step then, moving up from area and perimeter, is to look at three-dimensional objects. And on three-dimensional objects, we'll be looking, of course, at volume and surface area. So let's start out with a simple box. And let's say our box here is 20 inches by 12 inches by 8 inches. Volume. I'm going to find the area of the base. The base, since it's a box, is just going to be the bottom. That's 20 inches by 12 inches, or 240 inches squared. So then for volume, what do I do to that? Times the height. So 240 inches squared times 8 inches, which is going to give us 1,920 inches cubed. That's our volume. Now we could have done simply length times width times height. That would have given us the 1920 as well. Because it's a box, that formula does apply. For surface area, we have the area of the base of 240, and of course there is a second base on top that's also 240 square inches. So all we need is the lateral area, which is the area of these lateral sides that connect the bases, those 4 rectangles that go around. And for lateral area, remember it is the perimeter of the base times the height. The perimeter of the base is just 20 plus 12 plus 20 plus 12, otherwise known as 64 inches here. So that lateral area is 64 inches times the height of 8 inches. Which is 512 inches squared. Adding those all up gives us a surface area of 992. Now on this test, calculating the volume will be required. Finding the surface area will be extra credit. There will be 4 surface areas on here, all 4 of them will be extra credit. So it's very, very possible to get above 100% on this test. And I have had several students do it through the years. Yeah, that's fun. Let's change that up a little bit. I think I've used the example of 6 several times in class. So let's use a 15-inch radius sphere. Volume is 4/3 times pi times radius cubed. So that's 4/3 times pi times 15 cubed. So 4 divided by 3 times 3.14 times 15 to the power of 3. 14,130. That's in inches, so this will be in cubic inches. So that's our volume for a sphere. What's our formula for surface area? Four times pi times radius squared. Very good. So this is 4 times pi times 5, or 15 squared, which is going to give us 2,800 26 inches squared. Is that correct? Perfect. So the sphere you can see is relatively easy. A cylinder with a base of 8 feet and a height of 12 feet. For volume, what's our first step? Area of the base. The base of this thing is the circle, so how do we find its area? Perfect. Pi times radius squared. What's the radius here? 4, half of the 8. So pi times 4 squared will be 50.24. Those are in feet, so that'll be square feet. So then the volume is found by taking the area of that base, 50.24 square feet, times that height of 12 feet, which is 602.88 feet cubed, correct? Any questions there? So for surface area, I've got the area of the base, 50.24, and that is going to happen twice because there is a second base on the top. Lateral area, remember, requires the perimeter of the base. How do we find the perimeter of the base? It's going to be a circumference. So pi times 8, pi times diameter. So 25.12 feet. So that makes my lateral area, that perimeter of the base, 25.12 feet times the height of 12 feet, which gives us a lateral area of 301.44. Is that correct? So we can get a surface area of 401.92 square feet. Questions? How are we feeling so far? Remember, it'll only hurt for a little while. So on our cone, To find volume, we start off again with area of the base. Once again, the base is a circle. So it is pi times radius squared. So it'll be pi times what number squared here? 7 squared, good. The 14 is the diameter, so we have to use 7 as radius. Giving us 153.86. And that is in inches, so this will be inches squared. So my volume will be the 153.86 square inches times what? Oops, that's a 24. But of course, since it is a cone or a pyramid, we divide by 3. So it's like 12, 20, we'll do it the easy way. 12, 30.88 inches cubed. That's our volume. Surface area becomes somewhat more difficult. We still have the area of our base, the 153.86 square inches. But there's only one base here, so we just have the bottom. It's really the lateral area that becomes significantly more difficult. Because first of all, we're not going to use the height of 24 anymore. We need to use the slant. Very good. And to find that slant, we will use the 24 squared along with the radius squared. Very good. So 7 squared plus 24 squared equals that slant squared. 49 plus 576, which is 625. When we square root that, we get that slant is 25 feet, or 25 inches. Next, we need the perimeter of the base, which is a circle, which will be pi times diameter, pi times 14. Give us 43.96. So the lateral area here becomes that perimeter of the base, 43.96 inches, times that slant of 25 inches, divided by 2 because it's triangles. So 549.5. So that all adds up to give us 703.36 square inches as our surface area. So here we have a pyramid with a base that's 16 by 16 and a height of 15. Where do I start my volume at? Well, the area of my base is going to be found by doing what? Yeah, 16 times 16, yes. So 256 inches squared. It's just a rectangle or a square, 16 by 16. So then the volume, the area of that base, times the height, 15, divided by 3, is 1,280 cubic inches. Surface area. We have the area of the base, which is the 256 inches squared. For our lateral area, we need the perimeter of the base, which is just 16 plus 16 plus 16 plus 16, or 64 inches. But then we also need the slant. How do we find the slant here? Well, the height of this gray triangle is going to be the height of the pyramid of 15 inches. What's the base of this gray triangle going to be? 8 inches, half of our base, which is 16. So we've got 8 squared plus 15 squared equals that slant squared. So 64 plus 225, which is 289. So we square root. That slant is 17 inches. So our lateral surface area becomes the perimeter of the base, 64 inches, times that slant, 17 inches, divided by 2 because it is still triangular. Which is 544 square inches. We add that up to get that our surface area is 800 square inches. What do you think? Still better than a sharp stick in the eye? No. We're going to shift gears a little bit and talk about graphing. So we're going to look first at algebraic graphs. Remember, in an algebraic graph, what we're looking at is something like y equals 2/3 x minus 4. Where would you start with that graph? Careful. You've got to start out with the y-intercept, the down 4. It's the number that's away from the x that we start with. So from our origin, from our center, we go down 4. That's our first point. Now from there, you had the other part, right? From there, what do we do? Up 2 and then over 3 to the right. That gives us our second point right there. So there's our line. It's not always quite that simple. We have y minus 3 equals negative 1/2 x minus 1. What do we have to do that before we can graph it? Yes, we have to get rid of the negative 3, and we're going to do that by adding 3 to both sides. So adding 3 on the left leaves us with y. Where do we add the 3 on the right side? To the negative 1. So we've got negative 1/2 x. Negative 1 plus 3 is 2. So where do we start graphing that one? Go to positive 2, yep. Remember, the negative is only the rise, up or down. The run is always going to the right. The run is always positive. So it is down 1, and it's still over 2 to the right. Of course, we can also run into something like this. 3x minus 2y equals 4. What do we have to do with this to make it graphable? We have to get the y by itself. So I've got to get rid of the 3x and the minus 2. The first thing I get rid of is the 3x. It's a positive 3x, so I'm going to subtract 3x. So I now have a negative 2y equals 4 minus 3x is just 4 minus 3x. And now I have to get rid of the negative 2. It is multiplying y, so I'm going to divide by negative 2. And remember, when we divide, we have to do it to every digit. So the negative 2's divide out there, leaving me with y. What is 4 divided by negative 2? Negative 2. What is negative 3x divided by negative 2? $1.5, yeah. So remember, the trick is you just take the 3 over the 2. It's a negative divided by a negative, so it became a positive. 3 divided by 2 is just 3 over 2. So now graphing that, where do we start? At the negative 2, very good. From there, up 3 to the right 2. There we go. That is graphing, or algebraic graphs. How would I graph y equals 1? Very good. You go up 1 and there's no slope, so it's a flat line. How would I graph x equals negative 3? Perfect. If y equals a number is a horizontal line, x equals a number has to be a vertical line. It's at negative 3, going vertically. Any questions there? Next, we need to look at data graphs. Data graphs are just that, representing data. Now remember, there are really only a few types of graphs, depending on what type of data we are using. A bar graph or a histogram is just bars. The difference between a bar graph and a histogram is on a bar graph you have labels here, and on a histogram you have number ranges. Like you might have 20 to 24, 25 to 29, and so on. That would be a histogram if it's got the numbers down there rather than labels. Up the side is always going to be some sort of scale. Now, the second difference between a bar graph and a histogram is if this were a bar graph, there'd be separated bars like this. In a histogram, what happens to the bars? Yeah, they're tight together. They touch each other. Like that. We could have a pie or circle graph. And let's say we have that favorite color graph again. And let's say out of our people surveyed here, we had 7 choose blue, 6 choose red, and 12 choose green as their favorite color. To graph these, we need to know the total. What do those add up to? 25. And to make a pie graph or a circle graph, we need to turn them into percents. It's still a frequency, it's just a percent frequency. Where my 2 disappeared to? There it is. So we're looking at 7 out of 25 is how much out of 100? We cross multiply and divide, we get that is 28%. 6 out of 25 is how much out of 100? Cross multiply and divide gives us that's 24%. And of course, we have 12 out of 25 is blank out of 100. If we cross multiply and divide, that'll be 48%. So in our circle here, I'm going to start out with, I'll keep this black. I'm going to start out with the red. 24% is almost exactly 25%, almost exactly a quarter. So that's just ever so slightly less than a quarter. Blue is 28%. That's ever so slightly more than a quarter. Green at 48% is just slightly less than a half. So there we are. Pretty simple. The one that people tend to mess up is the line graph. Remember, on a line graph, there's always time across the bottom. Let's look at the time you spent studying. Let's say on Monday, you spent 2 hours studying. On Tuesday, you spent an hour and a half. On Wednesday, you spend 3.5. Thursday, you spend 2 hours. Friday, you don't study. Saturday, you spend an hour. Sunday, you spend 3 hours. So we can graph the time spent studying over time. Now, typically, this down on the bottom here, I did days of the week. It could be years, could be months, any progression of time. But on a line graph, time always goes on the bottom. And then it is time to talk about statistics. From the statistics, you will need to know how to find a mean, a median, and a mode. You will need to know how to find a range. And a standard deviation. I wouldn't give you more than 6 or 7 numbers at most for a standard deviation. You will also need to be familiar with z-scores. For example, which is more expensive? Let's say you go to a doctor and he gives you an x-ray and charges you $400. Then the doctor gives you a shot, charges you $120. You think both of those are steep, but you want to know which is more expensive. Let's say that nationally, the mean for an x-ray is $320. The mean for the shot you were given is $90. The standard deviation for the x-ray is 40. The standard deviation for the shot is $12. We're going to compare by finding a z-score. For the x-ray, the z-score would be found by doing what? Yeah, 400 minus 320, and then dividing by standard deviation. So 400 minus 320 is 80. Divided by the standard deviation of 40 is a 2. It's a positive 2. So what that means is the x-ray is 2 standard deviations above the national mean. Let's look at the shot. How do we find the z-score for the shot? 120 minus 90 divided by 12. So 120 minus 90 is 30 divided by 12 is 2.5. The shot is 2.5 standard deviations above the national mean. And then, of course, we have our beloved empirical rule. The empirical rule is this bell curve, and the center is our mean. And we go out in steps of standard deviations. Remember, these percents in here are constants. Let's say that you are told that the mean cost of tuition at a technical college in the state of Wisconsin is $164 a credit. The standard deviation of $8 per credit. So what that means is what goes in the center here? 164, good. As I move to the left, what goes here? You got it. 164 minus the standard deviation of 8. 156. What goes here? Subtracting another 8 gives us 148. And here, 140. Oh, where my 1 went. Going this way, what do we have? We take the 164 and add 8 to get 172. Here, plus another 8 is 180. And here, 188. So you might be asked, what percent would you expect to be between $148 per credit and $180 per credit? Well, 148 is right here, 180 is right there. I add up those percents, I will get 95%. If I ask what percent would I expect to be between $164 per credit and $180 per credit? Here's 164, here's 180. I'm adding up those percents, which gives me 47.5. Well, the good news is that's everything for the test. Or the bad news, however you look at it. If this whole review made sense to you, the test will go very smoothly tomorrow. Or tomorrow, on Thursday, I should say. I would recommend, probably I will get this thing processed and post right away. I would recommend watching it one more time at least before you take the test and doing careful notes off of it, because I did put some very subtle hints and some not so subtle hints that would be helpful on the test in here. Any questions?